5 questions, 5 minutes, okay? Once you're done, you will just click a photo and send it to me on WhatsApp. Assalamu alaikum, Hanifa. How are you?
Fine, sir. How are you?
Hanifa, let me just send you yesterday's lecture, okay? Because it must have been uploaded by now.
Yeah, I'll check. Sir.
Are you fine? What happened?
I have cold.
Oh, okay. You are in India right now, right? Acha, like you can speak if
Yes.
you want. Okay. Change of weather there. Then no. Yes, Rifat and Zad done. Send me whatever you have done. Please send me whatever you have done till now. Zad and Rifat. Okay. Yes. So please send me on WhatsApp, Zad and Rifat, both of you, on my WhatsApp. Yeah, guys. Rifat, what happened? Zad, just send a photo, no? No need to make PDF and all. So much time. Yes, Rifat.
Yes, sir, I'm sorry.
हाँ जल्दी भेजिए. Correct, Zad. Second one is okay, fine. Third one, fine. Fourth one is not correct.
Sorry, sir, I made a bond here. My mistake.
First one is correct. Second, okay. आपने तो सारा सवाल भी नहीं लिखा है. Fourth one आपने तो कुछ दूसरा लिख दिया. Please see. I think Zad, you also made a mistake in the first and second one, right?
Yes, I made CH3 bond.
Second one, and second one. First one तो सही है आपका. I think so, but आपने थोड़ा सा गलत तरीके से बनाया. नहीं ठीक है, first वाला, second वाला थोड़ा सही है. Please look at the answers. So first one is it is what? Hydration of alkene following Markovnikov's rule, right? It will follow Markovnikov. That means this is the carbon in which we will get OH. So this will be your product. Okay, Rifat, your answer is correct for this one. We have BH3, so it will be what? Anti-Markovnikov. And we will get OH on the less substituted carbon here. OH. Double bond will obviously go. Now, whenever we have this Grignard reagent, what you have to do? OH, and on that same carbon, just add CH3. Everything is same. On oxygen, you will add hydrogen. On the carbon, you will add CH3. On the oxygen, है ना? इन लोगों को हिंदी आती है, they can remember like this. Oxygen में hydrogen, carbon में carbon. है ना? You remember C double bond O is what? C double bond O is the main main two atoms. In that, oxygen में hydrogen, carbon में carbon. Similarly, here also, and this carbon में carbon. This carbon is coming from Grignard reagent. See here also, what we will be doing? Everything as it is. Oxygen में hydrogen, carbon में CH3 from the Grignard reagent. Now NaBH4, if you look here, we have two different groups. This is carboxylic acid group, COOH. And then we have this group, this is ketonic group. Right? This is ketone. Now, the carboxylic acid group, it cannot be reduced by NaBH4. We can only reduce carboxylic acid group by LiAlH4. That is why in this case, you will have product. This carboxylic acid will be as it is because there is no reagent which can reduce carboxylic acid. But this ketonic group, it will reduce to OH like this. Please write the answers. Zaid and Rifat and Hanifa, समझ में आया आप लोगों को?
Yes.
Yes, sir.
Okay. Please write it down. Let me know when you're done.
Done, sir.
Okay. Right, next. हनीफा लिख लिया आपने? हनीफा?
Yes, sir. Yes, sir.
Method of preparation of phenols. Please write. The next topic. Method of preparation of phenol. Okay, method of preparation of phenol. Make the first method. From benzene sulfonic acid. Okay, from benzene sulfonic acid. What is benzene sulfonic acid? Benzene sulfonic acid is benzene ring. Wait a second. Here we have benzene ring and SO3H group, sulfur and O3H. This is benzene sulfonic acid. And in this, if I add water, NaOH, then it will get converted into this hydrogen will be, this is what? Acidic hydrogen. And it will form SO3Na. SO3 negative and Na positive. Okay. Now, further, if I add NaOH at high temperature, how high temperature? If you remember, 623 Kelvin, okay, 623 Kelvin, and you will have pressure, high pressure also. High pressure. In that case, you will be getting, here you will be getting O negative, Na positive. After this, you will add water to get phenol. Now, there are questions comes, this benzene sulfonic acid. How can you prepare this benzene sulfonic acid? Okay, let me write it here. This is your benzene sulfonic acid. You can prepare benzene sulfonic acid by sulfonation of benzene. Benzene ring, if you remember from haloalkane halorine, if I will add here concentrated H2SO4, concentrated H2SO4, then what I'm going to get? I'm going to get this benzene sulfonic acid. Okay, this is sulfonation reaction, sulfonation of benzene. All right, this reaction. When benzene is treated with oleum. Oleum is actually a mixture of H2SO4 and we have SO3 gas. And whenever you keep H2SO4 in a very high concentration, SO3 gas, it eventually the SO3 gas, it automatically releases from concentrated H2SO4. There are fumes of SO3 gas that you can smell if you have H2SO4. Okay. Now, when benzene is treated with oleum, that is H2SO4 and plus SO3, it forms benzene sulfonic acid. On further reaction with NaOH at high temperature and pressure, it forms sodium phenoxide ion. Sodium phenoxide ion. And on further acidification, leads to formation of phenol. Okay, so here there will be H plus also with H2O. Done, guys?
Yes, sir.
Right, next. From benzene diazonium salts. Okay, please write. An aqueous solution of BDS, benzene diazonium salt, gives phenol on heating. Okay, that means what we have to do? We just have to heat the benzene diazonium salt. The benzene diazonium salt is from Sandmeier's reaction, you must remember N2 plus Cl negative. Now, obviously, if I have aqueous solution, there will be water and I will heat it to get phenol. Okay, to get phenol. Now, how will we prepare this benzene diazonium salt? You can remember We prepare this from amines. Okay. NH2 and we treat this with NaNO2 plus HCl from 0 to 5 degrees Celsius. This is the condition that is required to prepare benzene diazonium salt. It's by decarboxylation. By decarboxylation of sodium salt of salicylic acid. Salicylic acid is a very important compound. You should remember it. Medicinally, it is very important. Salicylic acid, it is also known as aspirin. Okay, it is also known as aspirin. Now, what is salicylic acid? You have benzene ring, OH group, and in the ortho position, we will have COOH. But instead of COOH, we will have here Na because it is sodium salt. Okay, we'll have here Na. CO minus will be there, Na plus will be there. Now, if I add here NaOH, then what will happen? From here, from this whole thing, CO2 will cleave. Okay, so you can see CO2. Now CO2 has left and this has become ONA, sodium phenoxide. ONA, that is sodium phenoxide. Okay, so we have to heat it here. Then further, what is going to happen? I will add here HCl, or you can write H2O in the presence of H plus, any H plus, any mineral acid. In the presence of mineral acid, it will again become OH. At least now it is in the form of salt. Okay, O minus and Na positive. You add here H plus ion and it will get converted into acid once again. Done, everyone?
Yes.
Okay. So what will you write here? Please write here. Then I missed one more molecule here. You write here in the presence of CaO also. CaO and heat. Please write. When sodium salt of salicylic acid is heated with soda lime. Is heated with soda lime. What is soda lime? Soda lime is a mixture of NaOH and calcium oxide, CO. When sodium salt of salicylic acid is heated with sodium lime, it forms, this is sodium phenoxide. Sodium, then the phenoxide ion. Sodium phenoxide. And on further acidification, it forms phenol. Right, the next one. From Grignard reagent. Okay, so we'll have here phenyl magnesium bromide, a Grignard reagent with the R group as the benzene ring. This is benzene, MgBr. Okay, now we will oxidize this. That means we will add oxygen molecules. Okay, so we'll add oxygen molecules, O2. Generally, this Grignard reagent is present in the solution of ether, and on that ether we bubble the oxygen. So oxygen comes in with a pipe type of thing, and we bubble this oxygen gas into the Grignard reagent that is there in ether. Then what do we get? An insertion reaction happens, and we get OMGBr. We get OMGBr. Then on further acidification in the presence of any acid and water, we get OH. Okay, so please write. When oxygen gas is passed through ethereal is just like aqueous. Okay, ethereal solution of aqueous solution hota hai, वैसे ethereal solution. Yeah, that means the solvent is ether here. Ethereal solution of, this is phenyl magnesium ethereal solution of phenyl magnesium bromide. It forms an oxy compound, and on further hydrolysis it forms phenol. Okay, right, next, Dow's process. Fifth one, Dow's process. Dawes process. Now this reaction, you have already seen this reaction in haloalkane halorine. You have seen the chlorobenzene when it is treated with sodium hydroxide in high pressure and high temperature, it forms sodium phenoxide, and then for further hydrolysis with HCl, it gives you phenol. Okay, but this Dawes process is important because it is I would say that it is a commercial method of preparation. Okay, it is a commercial method of preparation. Dow is a company's name. Okay, DOW. It is a company's name. It is a chemical company. It's quite what I will say. How much is its net worth? It's a big chemical company. It has a, I think, somewhere around 150 billion is the net worth of net worth of Dow's company. Okay, and they started a process, Dow's process, for preparation of phenol. We have chlorine. The first step, what do? We add NaOH, 623 Kelvin temperature, and 300 atm pressure. We will get sodium phenoxide, ONA, because this is a basic condition. Then on further hydrolysis with HCl, we will get here OH, phenol. Okay, so they can directly ask you what is Dow's process. So please remember, Dow's process is in 2 chapters, haloalkane as well as alcohol. So bhuliega nahi. Okay. Now please write here. Phenol is commercially manufactured by heating chlorobenzene with sodium hydroxide at 623 Kelvin and 300 atm pressure. atm pressure in presence of copper salt as catalyst. In presence of copper salt as catalyst. This forms sodium phenoxide and on further hydrolysis with HCl gives phenol. This is called Dow's process. Right, next, from cumene. From cumene. What is cumene? Isopropyl benzene. Isopropyl benzene. Okay. We have here benzene, CH3 here and CH3 here. Okay, CH here and CH3 here. First of all, we react this with oxygen. Now, oxygen does an insertion reaction and we get a molecule. We have here carbon, okay, and this CH3s are as it is. We have one CH3 here. Let me just make some space. Oh. Okay, so this CH3 is here as it is. This CH3 is here as it is. Okay. Now, between this carbon and hydrogen, oxygen molecules comes in between with an insertion reaction like this. Now, further what we are going to do? Further we do hydrolysis in the presence of what? H plus and water. It leads to formation of phenol. Plus acetone. So it is commercially very viable because we get two very important molecules, phenol and acetone. Okay, so acetone is a solvent and phenol is used in many manufacturing units. Okay, so this process is very commercially viable. There are companies and manufacturing units in Gujarat also in India, which use this process for the preparation of acetone and phenol. Right, next. So when cumene is oxidized in the presence. Also, one more thing you can see that the starting material is what? It is cumene, that is isopropyl benzene, which can be easily prepared by the Friedel-Crafts alkylation of benzene. Then we are adding oxygen that is already very much available from the air. And the next one is water with some acid, okay, dilute acid. So the starting materials and the ingredients that you can see, these are very, very cheap. When cumene is oxidized in the presence of air, cumene hyperoxide is formed, and on further hydrolysis with H2SO4 gives phenol and acetone. Okay, so see, I have given you 6 reactions. Okay, method of preparation, how many? We have given you 6 here. Now in your NCERT, there is only 4. Okay, in your NCERT, there is only 4. Now it's your duty. What you have to do? For example, this cumene one is there in your NCERT. So what you are going to do? You are going to write in bracket in the heading only. It is present in NCERT. Okay. Similarly, you will see another method of reaction. You will see whether Dawes process is there or not there, right? Then you will see whether this from Grignard reagent it is there or not there. Whether this from decarboxylation it is there or not there. From benzene diazonium salt it is there or not there, right? Similarly, from benzene sulfonic acid, is it there or not there? And you will write in the side NCERT. Okay, so that when you are revising these things, then you will be focusing. Okay, fine. I'm preparing for boards, then I will focus on these NCERT ones. Okay. So this method of preparation is done for both alcohols and phenols. Now please write a homework. First will be one-page reaction map covering all the methods of preparation of alcohols. Second, one-page reaction map covering all the methods of preparation of phenol. Okay, please write this down homework. One-page reaction map for covering all the methods of preparation of alcohols and one-page reaction map covering all the method of preparation of phenol. Okay. Once you're done, write the topic. Physical properties of alcohol. Physical properties of alcohol. लिख लिया आप लोगों ने? So write the first physical properties. The first physical property, it is the physical state. Okay. Now, if you are going to see alcohol, what is the physical state of alcohol? Okay. Number one, physical state. Now, physical state will be smaller, or you can say the lower members of alcohols are right here. Lower members of alcohols are liquid with characteristic smell. Okay, with characteristic smell. Higher members, that is more than 12 carbon atom. Okay, if they are having more than 12 carbon atom, then they are colorless wax-like solids. Write this down. Next, we will look at the boiling point. Next, we will look at the boiling point. Why we are looking at the boiling point? We are looking at, first of all, the boiling point because they are liquid in nature. They are liquid in nature. Okay. आगे बढ़े?
Yes.
Please write. boiling point of alcohols and phenols increases with increase in number of carbon atoms. It increase in number of carbon atoms. Okay. Achha. One more thing is that, so before this point, wait a second. If you have written this point, that's fine. So I'm going to explain kar lenge baad mein. But before that point, we will write why the boiling points of alcohols and phenols. Alcohols generally, these are greater than the corresponding alkanes and the corresponding haloalkanes and the corresponding ethers also. Okay. And the ethers also. Right, next point. Boiling point of alcohols decreases with increase in branching. Okay. So boiling point is inversely proportional to branching. That is why you will see the primary alcohols, they will be having highest boiling point. But you have to remember the number of carbon atoms should be same, followed by secondary, followed by tertiary. Okay. So if you have, for example, you have, let us say something like this. 1, 2, 3 carbon, 4 carbon, and then OH. This will have the highest boiling point, followed by 2 degree, and followed by so all of these are having same number of carbon atoms. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, and then 4th carbon atom here. Okay. The primary has the highest boiling point there. Fine, 2 points we have written. Furthermore, you can also write one more thing. This is due to branching. You can write CH3OH. It has lower boiling point than ethanol. Ethanol has lower boiling point than propanol. It has lower boiling point than butanol. This is due to number of carbons. Okay, this is due to number of carbons. After this, you write a note, and this has been asked multiple times in your CBSE examination. Okay, this is important in the CBSE examination. Please write boiling points of alcohols and phenols. Alcohols and phenols are higher in comparison. To hydrocarbons. That means alkane, alkene, alkyne of equivalent weight, comma, haloalkanes, and ethers. Okay, and ethers. Boiling point of alcohols and phenols are higher in comparison to hydrocarbons, haloalkene, and ethers of comparable molecular masses. Okay, explain. Right answer. This is due to the presence of hydrogen bonding. Yeah, correct. Due to the presence of hydrogen bonding between alcohol molecules and between phenol molecules. Let me not write, okay, just write due to the presence of hydrogen bonding. फिर आप लोग कंफ्यूज हो जाइएगा कि अल्कोहल और फिनॉल के बीच में हाइड्रोजन बॉन्डिंग नहीं होता है. I will show you the hydrogen bonding. You have R, O, and let us say you have something like this. R, O, H. Okay. And here you have oxygen, you have R, and here you have hydrogen. This will form another hydrogen bond. Okay, this will form another hydrogen bond. Similarly, you can also have here something like this, oxygen, and then hydrogen, and then here you have R. So this will be forming hydrogen bond. This will be forming hydrogen bond. Similarly, you can have here some, let us say oxygen, hydrogen, R group. Okay. So this type of hydrogen bonding is there. And this is between molecules. That is why the boiling point increases.
Said it.
Done?
Yes.
Okay. Then what is next? So here also you can write an example like this. If you have R, let us see what you have. RH, this is alkane. If you compare this with RCl, this is chloroalkane. RBr, and you have ROH. Then alcohol will be the highest, followed by Br and chlorine. Okay, this is due to intermolecular hydrogen bonding. Okay, and if you compare, let us say CH3O, CH3, and we have here CH3, CH2OH. So both of these will have same number of carbon atoms and oxygen atoms. You can see 1 carbon, 2 carbon, and we have 3, 2, 1, 6 hydrogen. Here also we have 2 carbons and 6 hydrogen, but here alcohol will have higher boiling point due to the presence of hydrogen bonding. Similarly, you can do comparison between benzene, chlorobenzene, and alcohol. Phenol will have higher boiling point. Right, next, solubility. Right, next, solubility. Alcohols and phenols are soluble in water as they can form hydrogen bond with water. Okay, and you will show it like this. Okay, so this is the hydrogen bond that has been formed. Next point you will write. एक चीज पहले हम आप लोगों को एक्सप्लेन कर देते हैं. Alcohol molecule, it contains two parts. Okay. Now this green part here, which is the hydroxy part, it is favorable for solubility. Favorable for solubility. That means if there is OH bond, that means it will be soluble. Okay. Now this R group here, it is completely non-polar. It is complete. It does not have any hydrogen bond. That means it is what? It is unfavorable. It is unfavorable for solubility. That is why if I increase the number of carbon atoms, okay, so there is always two things, favorable thing and one unfavorable thing. A favorable thing is a constant, only OH, one OH per, let's say one OH per alcohol. But if the R group starts to increase from methanol, ethanol, propanol, then the unfavorable part of solubility is increasing. And as the unfavorable part of solubility will increase, the solubility is going to decrease. That is why on increasing the number of carbon atoms in alcohol, the solubility decreases. As the larger alkyl group prevents the formation of hydrogen bond with water. Okay. So right here, order of solubility. CH3OH, it will be more soluble, followed by ethanol, followed by propanol, and at last you will have butanol like this. Done. Right, the last point. With the last point. In isomeric alcohols, the solubility increases with increase in branching. Solubility, it increases with increase in branching. Now, I hope you guys remember that if we increase the branching, then what is increasing? The surface area of the alkyl part is decreasing. No? So, an increase in branching as the surface area of alkyl group decreases, okay, as the surface area. That means if I have, let us say, this is butanol, it will be having the lowest solubility, followed by butane 2-ol, and highest will be for N-butyl alcohol. Okay, why? Because if I increase the number of, if I increase the branching, then the surface area of the alkyl group, it is getting more and more spherical. And if you have the same volume, because the number of carbon atoms are same, the volume, if the surface area of what? The sphere is the smallest. Okay. To compare the same volume of rectangle, sorry, not rectangle, I should say cuboid and sphere, then sphere will have lesser surface area. And since the surface area is less, that means we can say the unfavorable part is less and the favorable part is comparably more here when we increase the branching. And that is why the solubility increases with increase in branching. Solubility increases with increase in branching. Okay, right, last note. Phenols are less soluble than alcohols due to the presence of bulky benzene ring. Done everyone? Yes or no, please tell me.
Yes.
Yes, sir.
Now write it. Next, chemical properties of alcohol. Chemical properties of alcohol. Let us study the structure of alcohol first of all. Okay. We have R, oxygen, and hydrogen. This oxygen, it has lone pair electrons, and there are 2 lone pair electrons. Right? There are 2 lone pair electrons here. Now, if this lone pair electron, it attacks on a carbon atom. Okay, if it attacks on a carbon atom, then this oxygen atom is attacking on carbon. That means it is acting as a nucleophile. Okay. Now, if you have electron-rich source, then it can either act as a nucleophile, or what it can do, it can act as a base also, right? So if it acts as a base and it attacks the hydrogen atom, for example, let us see, it attacks the H+ ion here. Now, if it attacks the H+ ion, what I am going to get? I am going to get here R, oxygen, one hydrogen and the other hydrogen. Okay. Now let me do one thing. Let me write it like this. Let me not write R here. Let me write here RCH2. Okay. Do अभी आप लोग मत लिखिए कुछ CH2 and R here. So what I'm going to get? I'm going to get here R CH2 oxygen with one hydrogen here, another hydrogen here. This oxygen will get a positive charge. This oxygen is going to get a positive charge. Now, you know what is going to happen whenever we get a positive charge on oxygen, this bond, it becomes very much polarized and this bonds break. Oxygen takes all the electron because it is electronegative as well as it is having a positive charge. Then as soon as the alcohol, it attacks the H plus N, it is going to give you a carbocation. It is going to give you a carbocation like this. Okay, so the OH, it automatically does not cleave, but as soon as it will attack H plus ion, I will be getting here R CH2 positive. That means a carbocation. That means what? Carbocation. Now this particular carbocation is an electrophile. It is an electrophile. That means protonated alcohol, they act as electrophile. But if you look at just alcohol in the presence, this is what it is acting as a nucleophile here. It is acting as a nucleophile. Now, what is going to happen when this oxygen, it attacks some carbon atom? Let us say some carbon atom with a positive charge. CH3, CH3, CH3 and a positive charge. It attacks here and I will be getting what? What will I get? I will get, let me take some other color. Yeah. I will get here R CH2 oxygen. Now this oxygen has been joined with this carbon atom, which is having 3 CH3 groups. Okay, 3 CH3 groups. And next we have the hydrogen as it is and positive charge on what? Positive charge on oxygen atom. Now, what is going to happen now? What is going to happen? This hydrogen is going to leave. This hydrogen will give electrons to oxygen atom and it is going to form R CH2 carbon with 3 methyl groups. Now, the thing that you have to see here is if I'm acting as a what? If I'm acting as an electrophile, in this case, what is going to happen? In this case, carbon-oxygen bond is breaking. And in this case, oxygen and hydrogen bond is breaking. Okay, oxygen and hydrogen bond is breaking. These are the two types of reaction that alcohol will show. So you'll write here ROH. It can show two types of reaction. Cleavage of CO bond and the cleavage of OH bond. Okay, so these are the two different reactions that alcohol can show. Versatile compound, you can say.
So in the book,
Yes.
So in the book, it is written versatile compound alcohol as nucleophile.
Versatile का इंग्लिश जो मीनिंग होता है ना वही मतलब है, यहाँ पे केमिकल कोई मतलब नहीं है. वर्सेटाइल का मतलब होता है हर चीज में जो काम आ जाए. जैसे स्विस नाइफ होता है, राइट? यू नो व्हाट इज स्विस नाइफ?
I didn't hear. Okay, Swiss.
You don't know what is Swiss knife?
No, sir.
No, okay. For example, you can say even mobile phone. Mobile phone is a versatile tool. Many things we can do many things with phone, mobile phone, right?
Yes.
Similarly, alcohol, because it shows versatile का मतलब ये नहीं, कोई chemical meaning नहीं, English वाला meaning नहीं versatile का.
Okay, sir.
So we'll first of all see the cleavage of OH bond. Now, if the OH bond is breaking, it is showing the acidic character. Okay. So first of all, write the topic. Reactions involving cleavage of OH bond. Number one. Reaction with metal. Okay, so in reaction with metal, topic is metal, but we generally see here the acidic nature because the OH bond is breaking. Okay, first one is reaction with metal. Please write. Alcohols. Alcohols are weak acids, and hence they react with, active metals such as sodium, potassium, magnesium, and aluminium, such as these metals, and forms H2 gas and metal alkoxide. Okay, so if you have any alcohol plus metal, it is going to give you RO negative and the charge on metal. Okay, the charge on metal plus it will give you H2 gas. You can balance H2 gas. You can balance the reaction by writing here 2 and 2, but generally in organic chemistry we don't need to balance. आप ऐसे याद रखिए. Alcohol, metal. This is metal, alkoxide, and hydrogen. You can write some example like this. OH plus Mg. ये important है यहाँ पे because see Mg is what? Mg is having 2 positive charge, right? It can liberate 2 electrons. That is why here you are going to get O. This whole thing will be twice and then Mg. Okay. MgCl2, right? MgBr2. Similarly, this alkoxide ion will also be twice plus H2 as it is. Further, you can write if you have, let us say, aluminium. So in aluminium, if I'm using this ethanol, aluminium can liberate 3 electrons. That is why we'll have CS3, CH2O, whole thrice, and aluminium plus H2 gas. Done?
Yes.
Okay. So abhi yahin tak likhe. Now in the next class, what we are going to do, we are going to compare the acidic character of water and alcohol, which is going to be a good better acid. Okay. Abhi yahin tak likhe. So what we did today, we did mainly 2 things. Method of preparation of phenols In that, you have to choose the 4 in CERT reactions. Okay, write them. Okay, you will learn them by writing it. Okay, you learn them by writing it. Then we learn the physical properties of alcohols and phenols. 2 things here important is the alcohols they have and phenols they have high boiling point due to intermolecular hydrogen bond. Next, we learned that the boiling point is directly proportional to the carbons and inversely proportional to the branching. Now, regarding solubility, we learned that these are more soluble than the different hydrocarbons because it is having hydrogen bond, right? Why they are soluble? Because due to hydrogen bond with H2O, they can form hydrogen bond with H2O. Now here we saw that the solubility is what it is inversely proportional to the number of carbons because the carbon chain is not soluble, right? It is unfavorable for solubility. And it is directly proportional to the branching because if I increase the branching, the size of alkyl group will decrease and then we will get more area for the formation of hydrogen bond. It's directly proportional to the branching. Okay, so these are the 3 things that we learned today. Please start revising now. Okay, please start revising now. Achha. Did I ask you guys for daily practice questions? On haloalkane and haloarine? Did I talk about this? Yes or no?
No, sir.
No? Okay, fine. See. First thing that we are going to do is save my number on WhatsApp. Okay. Now you will get daily. Daily ka matlab, I will not give you questions daily. I will not give you questions on Friday, Saturday, Sunday because you have on Friday holidays there. Have to prepare for the next class and Saturday, Sunday. Daily questions. On haloalkane and haloarine. Okay. And you have to send answers on same day. Okay. And this part, whatever I'm writing here, it is not related to assignment. Okay. It is not the replacement of assignment. Not replacement of assignment. Okay. This is just for the revision of the previous chapter because in assignment, you get the questions of this chapter. And in the practice question, I will send it to your WhatsApp. Okay. And you have to send me on the same chat